Okay, this is a solution video to problem number 8 on this packet, the more kinetics practice packet. And there are a couple problems in this one that are a little bit different than what we've seen so far. Specifically number 7 in solving for the rate law, and also in number 8. So I picked number 8 only because it's a little simpler. It's a little, well, I shouldn't say simpler, it's a little shorter. So I picked that one to make a video on to explain how you have to solve these sometimes. Okay, so here it is. Here's number 8. And all 8 really asks you to do is to come up with the rate law. So to find the order on A and the order on B, and it looks like a problem that is like any other we've done. And so if it, at first when you so if you want to find M first, so again we would approach it like normal. So we want to pick 2 experiments where A is changing but B is staying constant, and so the best choice here is experiment 1 and 2. A changes, B stays constant. Notice my rate does change, so we do our ratios. So we're going to do rate 2 over rate 1, which will be the concentration of A at 2 over the concentration of A at 1 to the M and to the M. Remember, K drops out, it's a constant, and B drops out because it's a constant here. It's the same number. So 0.1 to the N, 0.1 to the N would cancel. So now I fill in my numbers. Rate 2 over rate 1 over A at 2 is 0.2, B, oh goodness, A at 1, sorry, raised to the M. And this is like normal, this divided by this is 4, 2 to the M, and so M becomes 2. So far, totally normal. I expect that you got that far on your own, and now we know that. Now here is the predicament. When we get to solving for the order on B, the problem is that normally we go back to our chart, we pick 2 experiments where B changes and A stays constant. Notice the problem here is that A never stays constant. So we run into this issue now of, well, how can I solve this if A is always changing? And you might think that it's impossible, but it's not. And it's not impossible only because we know now how changing A affects the rate. And we know that because we've solved for this order. We know that M is 2. And so we know how changing A affects the rate. And so we can use that within our problem to help us solve for N. And so this is what I mean. So you still want to pick 2 experiments where B changes. B has to change, but this time we're not going to pick 2 where A stays constant because it's impossible. So I'm going to pick 2 and 3 because B changes. Notice A does not. That's okay. We'll deal with it. So I'm going to pick 2 and 3, and I'm going to do 3 over 2 because it's, this one's the bigger number over here. So I'm going to do a ratio of rate 3 over rate 2. Now, here's where it gets interesting. Your K still drops out, of course, but your concentration of A at 3 and at 2 do not drop out. And they don't drop out because they're not the same. Now, normally, right here, we would put A to the M. I'm not going to do that this time because I know what M is. M is a 2. So I'm changing my color. But I know that. See, I have experimentally determined that. And so I'm going to put it into my equation. It's not an unknown to me anymore. But B's order still is an unknown. Okay, so now if you go to fill in your numbers, you're going to notice that you only have one known. That one unknown is going to be N, and so we can solve for it. So it's a little lengthy. But I fill in my numbers, just like before. Rate at 2, rate at 3. Be careful here that you're picking the right numbers. A at 3 is 0.4. A at 2 is 0.2. These are both squared. Now I'm going to do it like this just to make life a little bit easier for us, and that would have been the same thing as doing this. You know, it's in squaring that whole term. It's the same thing, same rules of exponents, just like I'm going to do right here, where b at 3 is 0.2, and b at 2 is 0.1 raised to the n. Again, notice I only have one unknown, n. So all I have to do now is evaluate this. So I do my math. This divided by this gives me 32. But then watch what I can do. I can simplify this. So 0.4 divided by 0.2, well, that's 2. This quantity right here is 2, but it's squared. So that's this. And then this, of course, is 2 to the n. Now, be very careful. You cannot multiply this by this. Your exponents, you know, you got an unknown exponent in there. You're not allowed to do that. So all we can do is simplify this a little bit. 32 equals, well, 2 squared, that's 4 times 2 to the n. We're trying to isolate this. Here I'm going to erase and move over to the left. Okay, so I'm just going to do this. So if I'm not allowed, I cannot multiply this, okay? I cannot call this 8 to the n. That's an illegal algebraic step. I'm not allowed to do that. What I can do, though, is take 4 to the other side. Notice it's being multiplied right now. So if I divide, this is gone. This is gone. 32 divided by 4, that's 8. 2 to the n. And so here is where, you know, you might have to play the guessing game, but obviously n isn't 1. And if n was 2, 2 squared would be 4. So naturally our next choice would be, well, what if n was 3? 2 times 2 times 2, and that's correct. So I have now solved for n. N is 3. And there's my rate law for this reaction. It's 5th order overall, 2nd order with respect to A, 3rd order with respect to B. And I have solved for an order that originally maybe we thought was impossible only because A was changing the whole time. So it's important to note that technically you can do this for anything. So all those times when we went through the tables and found, you know, we kept saying like, where's B changing but A staying constant, and we would find the ones that worked. Technically, you don't have to do that. If you know, like in this case, A's order, well, then you can pick any set of experiments that you want, as long as you know this number. And then you're, you know, algebraically accounting for the fact that that's how changing A changes the rate. And so you can do that whenever. It's still much easier to pick a set where they do cancel, because then you've got that much smaller equation, but it is possible to solve them just like this. So now knowing that, if you happen to be stuck on 7, because 7 had the same issue, number 7 on this packet. So if you were stuck on 7 before, my advice would be go back and think about, now that we've learned this, and see if you can solve 7 based on that. Plus, you should have a key, or you'll be getting a key soon, and hopefully that will help you if you were stuck.